All right, let's go ahead and take care of iron. So iron has a 3 charge, and it is aqueous, and it will yield Fe plus 2 aqueous. Okay, right here off the bat, you know that we have a plus. That's an ugly plus sign. We have a 3 plus charge and a 2 plus charge. So we are in fact gaining electrons. You know what? Yeah, I can write it there. Okay, we are gaining electrons, so red cat, gaining electrons is the cathode, okay? And that is in fact a difference of 1 electron. So on the most positive side, we are going to add 1 electron. Okay, let's take care of our copper. We got copper solid, that's elemental, so that is going to be a 0. And then you have copper 2 plus aqueous on the opposite side. This is a Leo, and Leo is an anoid. Leo is an anoid. All right, so we have a difference of 2 electrons, so on the most positive side you're going to write 2 electrons. Okay, so this is the difference. You have 2 electrodes on this side, and you only have one electron in the iron. So in order to balance, give me 1 second while I yell at my boys. Isaac and Alex, quiet please. All right, so to balance cell reactions and to calculate that is a nice looking E, the standard cell reduction or cell potential, you must reverse the second reaction. Okay, I know that sounds crazy. If you look in your books, it is a rule. Okay, so I'm not going to list out the rules, you guys can read. So you're going to reverse reaction 2. The reason why we are going to reverse reaction 2 is when you look at our chart over here, you will notice that the reduction potential is in fact smaller. So why we are reversing reaction 2 is because the reaction 2 is the smallest number. Okay, hopefully that'll help. All right, so let's go ahead and let's find out what we would write. So we have copper solid going to copper 2 plus aqueous plus 2 electrons. Okay, and if we look on our sheet, that's okay, I lied, I don't want to write that. All right, so if we look over here, we're looking for copper 2, and we have copper, this is going to be right here. Okay, so if you look, it is right there. Now, this is where we have to reverse it. So this is not going to be 0.34. It is going to be a negative 0.34. And the way we would write it is like this, 0.34 volts. Okay, let's go ahead for ease. Let's write down, so let's rewrite it, okay? And when I say rewrite it, let's go ahead and take care of our electrons. Remember, we have 1 electron in the iron and we have 2 electrons here, so we need to find the common multiple. Well, let's just multiply 2 electrons to iron. So I'm going to rewrite iron in this case. So that plus iron 3 in aqueous solution yields iron 2 in aqueous solution. Okay, copper is going to be multiplied by 1, so we can just rewrite that. Aqueous plus 2 electrons. Okay, all right, so multiply them throughout. You have 2 electrons plus 2 Fe3 plus and 2 Fe2 plus. Okay, aqueous solution. All right, let's go ahead and write down our standard reduction potentials. Oh, okay, even I get confused on the certain terminology. Okay, so rewriting this, we have copper with a negative 0.34 volts. Remember, we had to reverse reaction number 2, and reaction number 2 was in fact copper. It was the smallest number. If you look on your page over here, on your reference, you will see that iron, okay, so iron over here, you'll notice you've got iron 3 plus an electron. There you go. It is 0.77. That stays the same. So we are dragging this over here, 0.77 volts. Okay. We are almost done, I promise. Okay, so let's go ahead and draw, because now we have to combine them. All right? It's the exact same thing that we've been doing with the half reactions, but now we are actually using a chart to give us the standard reduction potentials. All right, the cell reaction. What's going on inside the cell? What's going on inside the cell? Okay, this is what's going on. The copper solid is reacting with 2 iron with a +3 charge. Whoops, that's aqueous. Okay, and then you have copper 2 aqueous with 2 iron aqueous. Okay, now since we combined the 2 half reactions to form a complete reaction, we have to take our standard reduction potentials as well. So our standard potential cell, or standard cell potential, will look like this. Negative 0.34 plus 0.77. Okay, so it will look like that. You do the math, and your answer will be 0.43 volts. All right. Okay, not too bad, right? Okay, remember we reversed our second reaction because it was the smallest. Before reversing, this was 0.34. Iron was 0.77. Copper was in fact the smallest number, so we had to reverse it, meaning that we had to assign it a